Okay, we're now going to differentiate log of x and e of x. This is obviously an exponential. This is log base e. So remember, e is, or e to the x here, was the function that had the same gradient as the actual value of x, of e of x. So here, if we have y equals e of x, by definition, the gradient is equal to the same. Now that again is nice and easy for us, because what we can do is we can use the chain rule to differentiate any functions where this is slightly looking more difficult. So for instance, y equals e to the 2x squared plus 2, I can just substitute in here t equals 2x squared plus 2. That gives me dt by dx as 4x squared, no 4x, and here y equals e to the t, so dy by dt is just equal e to the t. Okay, and so dy by dx is equal to these two times multiplied together, so 4x e to the t, which is 4x e to the 2x squared plus 2. And it's pretty simple, and you should be able to do most of them like that. I'll do one more example. So here we have y is equal to 1 over e to the 7x cubed. Now that is e to minus 7x cubed. Remember our power rules. And I can do the same here. T is equal to minus 7x cubed. dt by dx is minus 21x squared. Here y will become e to the t. Therefore, dy by dt equals e to the t. Nice and simple. So dy by dx is equal to those two multiplied together, so minus 21x squared e to the t, which is minus 21x squared e to the minus 7x cubed, which is minus 21x squared over e to the 7x cubed. And that's it. Now log is slightly different. So here we've got log. If we have y equals log e to the x, we know that e to the y equals x. So if this is now round the other way as it from what it normally is. So if I differentiate x with respect to y, I get dx over dy equals ey, knowing that what we had before. Okay, and so I can say that if I reciprocate this, that or implies that dy by dx equals 1 over e to the y. Now 1 over e to the y is x, and so I know that's 1 over x. And so therefore, if I have y equals log e of x, dy by dx equals 1 over x. Okay, and that's just a standard differential that you can do. And it's the same rules apply before. Now, normally in the book you would see log e of x written as ln x. So you'll see that, but that's a natural logarithm, and as you go, if it's further on, generally it's implied for any log that it's done by the natural log. So let's have a go at an example. So y is equal to log of 5x cubed plus 3. Okay, and again we're going to do exactly what we do. We're going to use the chain rule, and we're going to say that t equals 5x cubed plus 3, therefore dt by dx is 15x squared. Here y becomes log of t, therefore dy dt is going to be 1 over t, and so dy by dx is equal to these two multiplied together, so 15x squared times 1 over t, which is 15x squared over t, which is 15x squared t in this case is 5x cubed plus 3, so 5x cubed plus 3. Okay, I'm not going to do any more than that. I'm going to let you have a go at exercise 4b and 4c. Do the odd questions, and they're to do with exponential and logs.